Section 11.3a is about radical equations. A radical equation is an equation with a variable in the radicand. Here's an example of a radical equation. It has an equal sign, which makes it an equation, and it's a radical equation because this variable is trapped by the square root. Now, one way you can think about this is that this variable is our damsel in distress, and she is trapped by the evil radical monster, and she has to be freed from the evil radical monster. Now, to solve these equations, we have to isolate the radical, and then we have to square both sides, because the only thing that will defeat the evil radical monster is a square, because squares and square roots are opposites of each other. So let's take a look at this. Right now, this x is trapped. We can't do anything with the x. We can't divide by 5. We can't isolate the unknown until the square root is gone, until it's defeated. And the way we defeat it is we square, because a square and a square root are opposites. And so when we square this, we cancel the square root symbol off, and we're left with a 5x. But what we do to one side, we also have to do to the other. 5 squared is 25, and now you can isolate the x just like you normally would. In this case, divide by 5, and so x equals 5. So that's how you solve a radical equation. You first isolate the radical, then you square both sides to get rid of the radical, and then you just isolate the unknown. So here we have some radical equations. This one I want to get the a by itself, but I can't because it's trapped by the radical. Before I can get rid of the radical, though, I first have to isolate the radical. So I'm going to start by moving the 7 over. So square root of a equals 7. Now that I've isolated the radical, I can defeat the evil radical monster by squaring him. And then canceling off the square root. Whatever I do to one side, though, I also have to do to the other. So a equals 49. Over here, I notice that the minus 3 is also trapped with the x, whereas over here the 7 is free from the square root symbol. So over here I can't add 3, that won't help me. So all I can do now is square it because I isolated the radical. So the square and the square root cancel. X minus 3 is 36. 6 squared is 36. Now I can add 3 to both sides. So I end up with x equals 39. So you always want to get the radical by itself so that you can square. In this example, the square root is isolated already with the letter, so I'm going to square both sides. On the right, they'll cancel, leaving me with a negative m. On the left, I actually have to square both of these numbers. I have to square the 4 and the 7. So this becomes 4 squared and square root of 7 squared. Well, 4 squared is 16. Square root of 7 squared is 7. And 7 times 16 is 112. And that equals negative m. But I don't want negative m, I want positive m. So we'll divide both sides by a negative, and then we'll switch it around. So m equals negative 112. In this example, isolating the square root by subtracting 5. So the square root of x equals 4. Get rid of the square root by squaring. So x equals 4 squared, which is 16. Last couple examples, the square root is isolated, so we will square both sides. 5y plus 4 equals 49, and now you'll solve it like you typically would. So y equals 9. Over in this one, the square root is not isolated. It's being multiplied by a 4. And remember, we have to isolate the square root first. So I'm going to divide by 4 to cancel those. Divide by 4. So we end up with the square root of x minus 5 equals 15 over 4. Now I can square both sides. And so x minus 5 equals 15 squared is 225, and 4 squared is 16. Now we'll isolate the x by adding 5. So this becomes a 225 over 16 plus 5 over 1. So now I need to get common denominator of a 16, so I'll multiply this by 16 over 16. So this is 225 over 16 plus 5 times 16 is 80 over 16. Put those together and you get x equals 305 over 16.